Hi, my name is Ming Leong, and I'm going to present to you our study on predicting the graduation on time (GOT) of Diploma in Computer Science students using artificial neural network. Our members are Adeline and Kamat and Ismariani binti Ismail. We are from the Computer Science Department of Universiti Teknologi UiTM Sarawak branch. 80% graduate on time GOT KPI is a great challenge for many universities. Many statistical and machine learning studies were conducted to better understand the factors contributing to students' successful graduation on time. However, overall visualization of students' direction of GOT as the key indicator is still lacking. Therefore, this study will develop a predictive model with visualization of student GOT. The key highlights of the developed model are two-dimensional view of students' results. Prediction accuracy achieved are between 78.32 to 97.06%, and it provides individual prediction shown on an overall map. Literature review. Our work can be considered as part of data mining, where data mining serves as the methodological exploration of intriguing patterns and information within specific data sets. Many studies such as naive Bayes algorithm, decision tree subvector machine, SVM, KNN algorithm, and many more have been tried to predict the student GOT in the literature. What we are looking into, what we are proposing will be to fulfill these criteria, where topologically preserving visualization, and there is some interaction predictive with visual guide, and that's why we propose this model called self-organizing map with modified adaptive coordinates, SOM-MAC. This is an overview of our proposed model. The main algorithm behind this model is self-organizing map and hybrid with these modified adaptive coordinates. These pictures here shows the conceptual idea of this self-organizing map SOM, where it consists of two layers. One is called input layers, that the dimension of the input layers is the same as the data being analyzed, and the output layers that often is represented by a grid-based visualization. After learning, the grid will review the topology patterns of the data, such as the one that shown here is the example of the SOM grid that shows two clusters of GOT and then non-GOT here. However, we do a bit more than SOM grid. We use modified AC to feed these neurons into really topologically preserved visualization of the data, where we can better see the connection between the neurons, where the distance actually means the differences between the weights of the neuron. So if the neurons are closely aligned together, they are similar to each other, but if they are far away from each other, means they are very different in terms of their weights. This is our data after cleaning. This is one of the semester that we use, the data that we use after being normalized, where this data, it shows from column 0 to column 9, it actually represents different grades or grade value of the subjects students took during that particular semester, and column 10 and 11 is the the GPA grade points average value and the CGPA cumulative grade point average respectively. And the last column 12 here, represent the labeling of that particular sample. So two here is actually represent these non-GOT samples, and one represent these GOT samples. So after we do the data cleaning, we feed this data, normalize the data, and this data actually feed randomly into the model, some MAC, by splitting the data into 80% randomly selected for training, and then the remaining 20% is used for testing. And this cycle is repeated for 100 times. As for the parameter setup for the self-organizing map, we use 5 × 5 square grid for some, and respectively we use 25 units for MAC, modified AC, and then the learning rate is linearly decreasing from 0.55 to 0.01, and then the sum neighborhood range is exponentially decreasing over the 100 epoch. This is part of our result after we do the training and testing. The results, first part of this result is the mean square error, is an indication that learning take place. It's around, for all the semester, around 40% or 40 epoch. The learning start converging, and then it just linearly, gradually decreasing, meaning the learning actually start to get saturated after around 40% of the total training period. So it is similar for all the semesters. Second part of the result is the some visualization, as well as this AC, modified AC visualization. What we can see here, shown here now, is 3 semester result. From the look of it, this visualization gives us an overview of the data itself, where we can, from this visualization, actually we can see, or we can see that these GOT results are very diverse. That's why they are widely distributed. But the non-GOT samples are very similar. That's why only very few neurons are activated by these non-GOT samples. And these are general observation. Data mining, the first part, we use these as an overview of the data, overview distribution of the topology of the data. And we can see that it is widely distributed for the for the GOT samples, but very similar samples for the non-GOT. That's why we have very few activated neurons for non-GOT. However, as we goes into 4th semester, now it become very clear that the non-GOT starts forming its own clusters, very clear cluster of non-GOT, and also it's quite clearly separated from the GOT samples. As we go into 5th semester, now it is very obvious. It's reverse of semester 1 to 3, where this GOT is very crowded together, meaning the data for GOT is very similar as compared to the diverse non-GOT samples. So this sum and AC give us an overview of our data, where we continue to explore into different different details of the data. This so as we look into this model predictive accuracy, as shown in this table 2 here, average prediction accuracy, we can see that the accuracy from semester 1 is around 78%, and semester 5 it is 97% prediction accuracy. It keep on increase one after another as semester. This actually shows a pattern that we see in the visualization themselves, where the forming of clusters of non-GOT is unclear for the first semester, but as we analyze semester 2, 3, 4 and on, the cluster become clearer and clearer. It's a pattern that confirm with this prediction accuracy as well. The last part actually is the most important part of this study, is not just give us an overview of the data. This trained map now can be used to predict individual students' result, even starting from semester 1, where sample from the students, their result can be fed into this map, and the map will be able to make prediction whether the student result is indicating whether it is, like this case, whether it's highly probable of graduating on time, or maybe it's quite highly risky candidates of failing or unable to graduate on time. This gives us very important and very simple yet very precise prediction of the students based on their semester results, that we can make prediction of their future semester if the pattern precedes. They are quite probable they won't be able to graduate on time. This is the result that we can get, or the value that we can get from the map that we have trained, so that we can use it to predict individual students of their respective probability of whether they can graduate on time or not. As a conclusion, this studies developed self-organizing map with modified adaptive coordinates, some MAC, capable of automatically monitoring students' academic journey in university. This map, this SOM MAC, give us an overview visual pattern of a batch of students for each semester, and with this overview we can use it to produce interactive prediction of individuals' probability of completing their study in time. So it is recommended to integrate this model into existing learning management system that would have greater impact on students' academic supervision and achievement. Thank you very much.